Okay, so in this video we're going to be reviewing the differences between systems and control volumes for fluid kinematics. Okay, so to start, let's kind of back up, even beyond fluid mechanics just for a second. And so, anytime we perform any kind of engineering analysis, we always do so on a subject, and that subject has a domain. And so usually, just as an example, this is the part or device that we wish to analyze. And so you might think of maybe a bridge or a building. Those might be the subjects and domain for structural analysis. Right? And so if you look at the bottom of the screen here, that's usually our methodology or usually the process that we go through to run an engineering analysis. So we choose our subject domain, we apply our our governing equations, and then we solve those equations on that domain to obtain the solution. Okay? And so for solid mechanics, selecting the domain is fairly straightforward. And so usually this is some kind of solid object, and that solid object has a fixed amount of mass and volume. But for fluid mechanics, this is not as straightforward because the flow is constantly in motion, or the flow is going, and so it makes it a bit difficult to choose the subject and the domain. And there's kind of different approaches to this. And so one such approach is the systems approach. And so the system approach is very similar to how you would think about a problem from a solid mechanics point of view. And so from a system approach, you choose a fixed amount of mass or substance, and then that is identified for the analysis, right? And so you would maybe think of selecting a block of concrete or a steel beam. And so for fluid mechanics, what this means is that we take a fixed amount of fluid and then we kind of tag it. And so what that means is that, as the fluid flows, we kind of follow that fluid as it goes. And so for this example here, I have fluid in a box, and then as it flows out of the box, we kind of follow that fluid as it goes. So in reality, this approach is not that useful for fluids because practically it's really difficult to identify and keep track of a fixed amount of fluid. And you can even see this in your own daily life too. And so if you go turn on the tap water, right, if you try to use your eyes to follow the same amount of fluid, the same, maybe 5 grams of fluid as it goes from your sink down the drain, that's really difficult to do, right? Even if you have some kind of dye to do it. And that's not to say, you might have cases where the flow is even faster and more complex, or even, even more basic. You might have flow that splits into two branches like you have here, right? So this makes it difficult to describe properties for that entire entity, since since the shape of this since the shape of the system can change, it can split, it might be hard to follow. This just really isn't a practical approach to doing fluid mechanics. And so a better approach is to use what's called a control volume approach, where instead of tracking a fixed amount of mass, you kind of draw, imaginary lines in the sand and then analyze this fixed volume in space. And we call these volumes control volumes. And so because this volume is fixed in space, fluid will flow into the volume and it'll flow out of the volume. And so, we're not tracking a certain amount of fluid anymore, but fluid's going to come in and out, okay? And so this is really kind of a natural way to think about it because, naturally when we think of fluid flow, like say, look at your faucet, we look at devices, we look at objects, and we think of fluids flowing through those objects, okay? And so now the analysis subject becomes the object or device that the fluid flows through instead of trying to track a fixed amount of fluid, okay? And so this is kind of a very different paradigm here because now, because the fluid's coming in and it's coming out, that fluid is going to bring with it a lot of physical quantities, mass, momentum, energy, angular momentum, etc. And it's going to change how we do our analysis, right? But it's through this control volume approach that we can actually get some practical solutions by applying our physical conservation laws. And you'll see how that's applied in future videos.